Alright, in this video we are going to cover concepts learned in lesson 4.2 and 4.3, and this is the study guide for module 4. Right? So if we start here on lesson 4.2, we're talking about multiplying polynomials together. And so on this one, you can see that there is a monomial on the outside and a trinomial inside. And so really what you're doing is you're just distributing that through to everybody, right? Just same distributive property you've used a lot of times before. So when we do that and distribute that through, that's going to give us 3 times 2 is 6. And then x, right, we got x to the second, so we need to add those exponents together, so that's going to be to the 4th power. So 6x to the 4th power will be our first term. Now let's distribute to our second term. So 3 times 5 gives us positive 15, so plus 15. And then x squared times x gives me x to the 3rd. And the last one, 3x squared times 3 is going to give me a positive 9x squared. And then we'd always want to look to see if there's any like terms we can combine together, but we can't on this one, so that one is done. All right, moving on to the next one. Now we have a binomial being multiplied by a trinomial. And again, it's still the distributive property that we're doing on this. Okay, and so I'm first going to distribute my 2x through to everybody. All right, and I'm going to write that over here to the side. So 2x times x squared is 2x to the 3rd. Because remember, I'm adding those exponents together. 2x times negative 4x is negative 8x squared. All right, remember there's like invisible ones on these. All right, we're distributing those through and adding those exponents. And then 2x times 6 is going to give me a positive 12x. All right, now I still need to distribute my negative 1 to everybody. All right, because all I did so far was just the 2x. So when I do this, I'm going to write it underneath what I wrote here in purple, making sure that I line up my like terms. So negative 1 times x squared is going to give me negative x squared, right, or negative 1x squared, however you want to write it. But make sure you line it up with the other x squared. Don't put it underneath the x to the 3rd, right? We're doing this to make it easier. So negative 1 times negative 4x will be a positive 4x, and negative 1 times 6 is going to be a negative 6. Right. And now I can combine these together. Right? I'm really just kind of adding these up. And so the x cubed term doesn't have anything to add with it, so it just comes down. So 2x cubed minus 9x squared plus 16x, and then minus 6. And that would be your answer on that one, on number 2 there. All right. Okay, on number 3, we're still multiplying things together. I'm going to put that one over here. All right, and we're multiplying binomials together. And you got to be really careful on this because it's saying x plus 4 all squared. And a common mistake that people try and do on this is distribute that power of 2 to everybody inside. You can only do that if it was connected by multiplication, but in this case it's connected by addition. So what we need to do is rewrite this, because that's really saying x plus 4 times itself again, so times x plus 4. And then I'm going to just FOIL these together, right? Remember that FOIL stands for first, outside, inside, last. But really what you're doing here is you're just distributing, right? So x times x is going to give me x squared. And then if I have x times 4, That will give me positive 4x. Right? And then I do the 4 times both of these. So 4 times x is 4x. And then 4 times 4 gives me positive 16. And then I just need to combine any like terms together that I have. And I can see I have some in the middle there. So my answer is going to be x squared plus 8x plus 16. Right? You can kind of see, what happened on this, and sometimes people kind of look at a shortcut, right? If you just tried to distribute that 2 through to everything, you'd get that x squared plus 16, but you would miss that 8x in the middle, which is a crucial part of it. So be careful there. All right, let's do 3b also. All right, so it's pretty similar. So we're going to take that 2x plus 3y all squared and just write it out as 2x plus 3y times 2x plus 3y. Right? And then again, we will distribute here. So 2x times 2x is 4x squared. 2x times 3y is positive 6xy, right? When I multiply all of those together. All right, now let's distribute the 3y. So 3y times 2x is another 6xy. And then the last term there, the 3y times 3y is positive 9y squared. And again, we want to get any like terms together that we have, which we do have here, right? So I have 4x squared plus 12xy, 6xy plus 6xy, and then plus 9y squared. So make sure you simplify it all by getting any like terms together on that as well. Okay, and then part C is going to be really similar to that, doing the same thing. So I'm just going to go ahead and skip that one, let you do that one on your own. Okay, but remember the answer key is on Canvas, so you can look at that. All right, let's keep going here. Let's look at some stuff in 4.3. In this one, we start talking about factoring. Remember, factoring is undoing this multiplication that we talked about in 4.2, right? Whenever there's a way to do something in math, there's always a way to undo it. So in this first part, we're actually going to be looking for the greatest common factor, right? And so when we're talking about greatest common factor, we kind of need to do it, each part at the same time. So I'm going to look at 32 and I'm going to look at 8. And I think, okay, what's the greatest common factor? What's the largest number that will divide into both of those? And that would be 8. All right, then I want to look at the p's next. All right, so I'm looking at the p's. So I've got p squared and I've got p. Well, with this one, you want the one with the smallest amount of p's, right? Because I can't factor a p squared out of this second term because there's only a p to give. So p, right? So 8p is what I have so far for my greatest common factor. And then let's look at the q part. So q to the 4th and then q, right? Now it's q to the 1st power. And so again, when we're looking at that, we want the smallest amount of them, so that's going to be q. All right, so 8pq is my greatest common factor on this. Whoops, rewrite that a little bit better. And then that is what I'm trying to divide out of each term. All right, so this is my GCF. All right, and then I'm going to have leftovers inside here. But how do I figure out what those leftovers are? Well, I'm going to divide each term by 8pq, right? And then divide this one by 8pq. and that will tell me what's left over. So when I divide here, 32 divided by 8 is 4. P squared divided by P is just P. Q to the 4th divided by Q is Q to the 3rd. All right, now we'll go to the second term. So 8PQ divided by 8PQ, right? That's just something divided by itself, so that's got to be 1. So plus 1. And this whole thing together is my answer, right? We have the part that we factored out and then the leftovers. If I distribute that 8PQ back through, I should come back with what I started with. Okay? All right, let's look at the next one then. Maybe I'll do part B over here. All right. So this one says 8x squared y to the 5th, and then plus 4x cubed y to the 2nd. All right, so again, I'm trying to find my GCF. What is the largest number that will divide into both 8 and 4? All right, well, 4 is. 4 can divide into both of those. All right, and then I look at my x's. So x squared and x cubed, I want the smaller amount of it, so x squared will be my part of my greatest common factor. And then I look at my y's. Y to the 5th and y squared. Y squared is the smaller one, so that's the one I want. And then I'll be putting whatever, when I divide that out, I'll put the rest of it in leftovers. So remember, I'm dividing both of these terms by the greatest common factor, which is 4x squared y squared. All right, so that's really what I'm doing here. All right. And so 8 divided by 4 gives me 2. So in the first term here, I'll have 2. The x squareds, right, I can see, oh, x squared divided by x squared is just 1, so there's nothing left there. But my y to the 5th divided by y to the 3rd, I'm subtracting those exponents, and so that will leave me with y to the 3rd. So y to the 5th divided by y squared is y to the 3rd. Okay, so my first term is 2y to the 3rd. Now I need to look at my second term. Well, 4 divided by 4 is just 1. All right, but y, or x to the 3rd divided by x squared, it's just going to leave me an x, and it's going to be positive here because we've got a plus sign here. All right, so plus x, and then my y squareds, again, y squared divided by y squared is just 1, so there's no y's left there. All right, so I kind of have this out here a little bit further than I need. So this will be my answer. All right, all of it together. So 4x squared y squared times 2y cubed plus x. And again, if I distribute that 4x squared y squared through the parentheses, I should come up with what my original question was to start off with. Okay. All right, and again, I'm going to skip part C. It's pretty similar to what we just did on the other two. So I'll get that one for you to just work through on your own. All right, on number 2, though, we're going to be doing something called factor by grouping. So whenever you have 4 terms, that's when you want to do this factor by grouping, right? So when you have 4 terms, which is what you see we have down here, x squared plus 2x minus 3x minus 6. Right? Remember, terms are separated with add and subtract signs. So we have 4 terms, so that's what we want to do. All right, so I'm going to go ahead and I'm going to split these up. Well, first thing I'd want to do is see if there's a greatest common factor like we did above. And I don't see anything that is common with all 4 terms. So then after that, I'm going to split these into 2 different things. I'm going to split it right here. All right, so now I'm looking for what's the greatest common factor of x squared and 2x. right? So I can see they both have an x in common. And then when I divide the x out of both of those, I'm left with x plus 2. Right? And then on the second half there, negative 3x minus 6, and you find a greatest common factor on that, and that's going to be negative 3. And when I divide negative 3 by both of those, I again get x plus 2, which is what I need to get. If these guys aren't the same, then it's going to make it difficult to get this factored, right? The whole thing we're trying to do here is get those the same, because now can you see that x plus 2 is really my greatest common factor. So that's going to come out, x plus 2 divides out of each of those, and then I'm left with the x minus 3. And so that's how that one factors. All right, so and again, if I FOILed this together, distributed those through, I should end up with those 4 terms that I started off with. Okay. All right, and then the last one on here is again another factor by grouping, but this one's a little bit, when we look at it, thinking, okay, if I split it down the middle like I did on the one above, all right, and I try and look at my first 2 terms, well, I've got 4a squared and then negative bc squared. So these guys don't have anything in common with each other. And so when that happens, it's better to switch some terms to make it so you can, find a greatest common factor. And so that's what I need to do on that one, is switch those. I'm going to move this one, do it over here a little bit too, so I have some room. So when I rewrite this one out, so this is 2b here. Right, that's going to say 4a squared, and then remember I'm switching those 2 middle terms, so minus a squared b minus bc squared, and then plus 4c squared. All right, and now I'm going to just make my little dotted line here to show where I'm breaking it. I'm just looking at the first 2 terms, and I see, oh, they both have a squared in common. So a squared is the greatest common factor that's going to come out. And then left is going to be 4 minus the b. Okay, and let's do the same thing over here. So I've got negative bc squared and 4c squared, so I can see that c squareds they have in common. So if I take out a positive c squared, that's going to leave me with negative b plus 4. And then I look at this and say, oh, those look different, but they're actually the same, right? I could rewrite this one as 4 minus b, right? And they would be both the same. Okay, so then if 4 minus b is my greatest common factor, that's going to come out. And then that's going to leave me with a squared plus c squared. And that would be my factored answer. All right, so that's 4.2 and 4.3.